Okay, so in the last video, we graphed points. We graphed scatter plots, right? We graphed it, a set of data. We had a table of information. We had x values and y values in our table, and we graphed them. All right, so we're going to do more with graphing, a little bit more. We're just going to talk about graphing today, and we're going to get to the distance formula, because I'm going to find the distance between any 2 points. All right? And so that's the big topic in today's notes. All right, so we talked about graphing a scatter plot last time. All right, so this is an example where I'm going to go from graphing a scatter plot to graphing a line graph. All right, sometimes it's helpful to do that, especially if I want to see the relationship between the values. So in this particular case, all right, well, we have data points that are consecutive, meaning they go in order, and we graphed a scatter plot. And so this is the scatter plot for this example, which I'm going to get to in a second. But all a line graph is when I've taken a scatter plot, a bunch of points that are consecutive, and then I connect each consecutive dot by a straight line. Alright, and then it makes it a line graph. So that's all it is. I'm going to connect my dots, and I'm going to draw them in between each point. We draw them as a straight line. Alright, straight line between my points. So it doesn't curve, they're straight lines when I go to graph from a scatter plot to a line graph. Alright, so an example would be this. Suppose this is the table. Alright, so I made already a scatter plot of the average monthly precipitation, can't spit it out, in Portland, Oregon. Alright, and so over, and that's, for some reason the 7 should have been a 13, I typed it out wrong, that should be a 13, so make sure you change that to day 13, not day 7, because we already have a day 7. Alright, that should be a 13, so just make that correction in your notes. That was just me mistyping something. Alright, so there's my scatter plot over 13 days. Alright, so this is the 13 months. Not days, months. So this would be my x values. Because it matters how much rain I got depending on which month I pick, right? So x is I can choose the month. When I choose the month, right, depends on which month I'm in, how much rain we got. And so the y value, the amount of rain, depends on which month I'm in, right? Some months get more rain than other months. Some months get less rain than other months. Alright, and so month 1, 2, 3, all the way up to month 13. Make sure you change that to month 13. And then these are the inches. So in month 1, we had 6.2, and then everything in between. And so I want to go ahead and already graphed it. Alright, so here's already a scatter plot of all of those points. Alright, so there's all of the points. So this would be the average participation in inches. Precipitation. I keep saying participation. And this is our month, alright, x value is month, y value is, so again, I already went and graphed these, and so this would be the scatter plot, right, there's my scatter plot. Now, when we want to go to a line graph, we just connect a line between each of my so again, the line has to go between my one point to the next, and so my first set of points would be these two, and so I just connect the line between and again, I'm going to try to, hitting. It's supposed to be a straight line, so as straight as I can get, and then my next set of points should be a straight line between those. Straight line, again, straight line between each. And so even though mine lines, because I'm on my tablet here, it's not as easy, they should be straight lines between the points, right? So you kind of take each individual point, and there is my line graph. Alright, that's it. I take my scatter plot, connect the dots. Between each dot, it's a line. So even though it doesn't necessarily look like it, there's supposed to be straight lines between the points. And so the next thing is, well, since I can now connect 2 consecutive points, the next thing that we're going to look at is, well, I want to know how much distance is between my 2 points. So if we're looking at this, how much is the difference in my precipitation from one month to the next, right? We want to know what these distances are between each of my points. And so that's going to be the next thing we're going to look at. Distance between 2 points. Alright, so now that we can connect 2 consecutive points, we want to find the distance. Alright, and this is actually in your books. If you look at the book, I just thought this table was really nicely done, so I figured, well, they already have a nice picture of it, so I'm going to use it here in my notes. And so we have any 2 points. Alright, you can pick any 2 points. So point 1 would be this point. Alright, so this would be my x value, y value from my first point, and then the second point, again, this would be my x and y value from the second point. I want to know what's the distance, how far apart are my 2 points. Right, well, what I have to do is I sort of have to figure out, well, how did I move vertically and horizontally? And so you use that. And so the difference between the x values, because there are two parts, right? There's the vertical distance and the horizontal distance. And so we figure that out. So the first thing we do is, well, we figure out the distance between my horizontal distance, the x values, right? That's this. The difference in how far did I move in the x direction. And then I figure out, well, how far did I move in the y direction? And then it's just the Pythagorean theorem, right? If you look at this, this is a right triangle. To figure out the distance here, this is the hypotenuse, it's the, again, the Pythagorean is the square of my hypotenuse equals the square of my legs, right? And the legs are the distances that I'm moving in the x and the y direction. And so the distance formula is just the Pythagorean in context to my x and y, my points. So in order to find the distance between 2 points, I solve for d, so I got to get rid of the square here from my Pythagorean. Well, I just take the square root of both sides, that gets rid of the square. And so the distance, right, because distance is always positive, you don't need the negative, you always want the positive. It's the square root of the square of the distance from my x, between my x values. That's all this is. This is just the distance between my x values. That's my one leg, plus the square of the distance in my y value. So this is the distance between the y values, right, which is that leg of my triangle. And so distance is, again, it's just a fancy Pythagorean theorem, right? It's actually the Pythagorean in context to lines on a graph. And there's the distance formula, which again, hopefully you know it. If you don't, this is one of those formulas you need to make sure you jot down and have. We will be using the distance formula. Alright, so the distance between any 2 points on an xy plane. So d is the square root of the distance between my x values, so I subtract my x values. So we take x2 minus x1 and square it, and add to that the square of the distance between my y values. So I take my y2 minus my 1 and square it. Now, what's y2 and y1? Again, as long as you're consistent, the first values should come from the same point and the second value should come from the same point. So as long as you're consistent, you're okay. Alright, so again, there's the distance formula, which now we're just going to practice. Alright, suppose that we have 2 points, 2 and -8 and -2, 3. So again, if we graph them, we're not going to, but you should be able to. I want to find the distance between 2. So if I connected the 2 by a line, I want to know that distance. Now, it's up to you. I'm going to let this be x1, y1, this be x2, y2. So using my formula, my distance is the square root of, well, I take x2 minus x1, so I take -2 minus 2, and then square it. Don't forget the square. If I'm going to forget something, I often forget the square. Add to that the distance between my y values. Again, make sure you're consistent. I started with this point in the x direction. I should start with that point in the y direction. So it's going to be 3 minus a -8, and that's squared. That whole thing squared. Alright, so follow order of operations. Take care of inside the parentheses first. And so this is going to be -4 squared. Remember, when we subtract a negative, it's really add. So that's 11 squared, right? 8 plus 3 is 11. And then square them out. So 4 squared plus 11 squared is 137. That's exactly what the distance is. And so if sometimes we want exact, we might leave it that way. But I'm going to go ahead and plug it into the calculator and find the approximate. Alright, so the approximate distance, if I type that out, is an irrational number, 11.705, and I'm just going to round 3 decimal places. Alright, so that's if I'm given 2 points. Next example is if I'm getting a plot. So suppose here's my scatter plot. And I've got a bunch of these points. I want to know the distance between the points -5 and -10. 5 and -5, draw the line that represents this distance. And so, it's this point, -15, -10, and this point, -5, +5, -5. Alright, so if I'm going to draw as close as I can my straight line, that's the distance I'm looking for. What's the distance between those 2 points? Alright, so I'm looking for that distance. So distance in this case, again, it's just up to you. As long as you're consistent with your subtracting, you can label it however you want. I'm going to let these be my 1s and these be my 2s. Keep doing x's. So this is x1, y1, x2, y2, and so writing out my distance formula. It's the difference in my x value squared plus the difference in my y value squared, again, as long as you're consistent. We take y2 minus y1, so 5 minus a negative 15. Alright, then I take y2, which is negative 5, minus a y1, which is negative 10. So be careful with the negative. There's lots of negatives going on here, so make sure negatives, again, negatives are my Achilles heel. So be careful with your negatives. So in here, it's going to be 5 minus a negative 15, which is really 5 plus 15, so this is 20 squared. This is going to be 5 minus a negative 10, which really is 5 plus 10. Negative 5, sorry. Negative 5 plus 10, so that's going to come out positive 5. Alright, so it's 20 squared plus 5 squared, all under my square root. Alright, simplify that, and I'm going to leave it exact first and then find the decimal approximate. So multiply that out, it comes out to 425, which is approximately 20.62. So if this were an application, then these represented numbers, that's how far they're apart they are. They're about 20.62 inches, centimeters, whatever the units would be on, but that's how far apart they were. Alright, so in this case it's just units. So they're about 20.62 units away from each other. Alright, so that's the distance formula, and we will be using it. And again, hopefully you've seen it before. Alright, but that's the distance formula. Alright, so I'm going to stop the video here and pick up midpoints in the next video.